Friends, from time to time I go back to review some of my work and remember them in my groups. Forgive me for being a bit heavy. In this case I would like to talk a little about my ideas about the number pi, and expose mine. A subject to review is my vision of the total logical structuring of mathematics and its geometric concepts. For me, mathematics is a pure and strict logical norm, and therefore these requirements are always and everywhere met. And with regard to the circumference and its magic and elusive number pi, it must also keep these principles of accuracy, mathematical logic, geometric logic, etc. And based on these premises, I would like to distinguish my pi number, the squaring pi, which I understand meets these requirements, from the current or algorithmic pi number, which I understand does not meet the most important ones. Let's see. 1. The circumference is perhaps the simplest and most regular geometric figure, and therefore it should comply with the standard and logical mathematical principle that all formulas for measuring and adjusting geometric figures are based on their structural parameters such as radii, diameters, sides, angles, perimeters, hypotenuses, legs, apothems, etc. It is not expected that parameters or numerical values that are not in these parameters will be used to construct or measure the geometric figure. That is, both mathematically and geometrically, the figures are composed, structured and measured by means of their parameters. However, the current algorithmic pi does not do it, but uses a series of values not connected to the parameters of the circumference, due to the fact that it seems that its results are getting closer to it. Logically, and if the geometry and its numerical values are serious and demanding, they should not give us the true final value. However, my pi number is based on a direct formula of these circumference construction parameters, mainly its diameter. For this reason, I believe that my pi number meets the first and obligatory condition, which is to be measured and adjusted with the values of its parameters, diameter. 2. Another interesting and simple way to adjust the squaring pi number is to use the phi number for it, as shown in the drawing. Asterisk. Of course, the squaring pi website details multiple properties and ways to see, measure and adjust this number. 3. Another property that I have observed in the circumference is that it can be perfectly inscribed within a square, which is also defined and built, its side, by the same diameter as the circumference. But it is also that, and from any circumference, we can go on inscribing and circumscribing other squares and circumferences to infinity, all of them being built and supported by the previous ones, that is, with the elements of some we build the structure of the others. Well then, all these squares and circles circumscribed between them to infinity should have the property, circumscription theorem, that any basic element of this structure, and in the form of an exponential formula, has a formula that is capable of measuring and adjusting all and each of the elements of all these circumscribed figures, one above the others. And yes, exponential formulas of my number pi, they can give us all the measures of the elements and circumscribed figures. Squaring pi website. But no, the current algorithmic pi does not comply with this property, and if it is applied, it moves further and further away from the correct measurement. 4. And finally, an observation or conclusion that I have obtained. Sometimes, many times, when I get a little bored I dedicate myself to squaring circles, and I have observed that many of the possible segments and arcs inside the circumference point to the place where we have to place the segment pi divided by 2, but they do not finish achieving their total accuracy, for which I understand that it is due to the fact that to find pi, the basic parameters, radius, diameter, etc., must be subjected to many roots and powers. For me the minimum root and key is 17. 5. Bending squares to obtain its inscribed circumference. As some of you tell me that you are interested in the philosophy and logic of my formulas to obtain pi, I will summarize the fundamentals. My idea and formulas to obtain the number pi consist of doubling rectilinear parameters of the circumference, diameter, inscribed square, circumscribed square, etc., by means of powers and roots of these parameters until obtaining the appropriate curve of the number pi. In the drawing I show you a way of explaining it, where a larger square with side pi is supposedly subjected to powers and roots until it becomes the square circumscribed to the circumference, and from here, doing the inverse operation, we can obtain the number pi. 6. The pi squared cycle, precision test. Preamble. For many years I have been surprised by the apparent persistence of the number pi in hide and evade from a clear sample of its definition and mathematical demonstration through formulas that show us its true value and situation. However, and from this cyclical formula or function, my feeling has changed and my doubts have been cleared, and I understand that the number pi has told us. Well, here I am, enclosed, located and measured by my own constructive parameters. You see me now? Friends, as some of you already know, I have my own point of view and proposals for the number pi. I understand that it has an irrational value, but not transcendental, and that it is totally related, integrated and measured by the construction parameters of the circumference, diameter, inscribed and circumscribed squares, etc. During these years of considering it like this, I have been able to verify that it has more logic and with greater mathematical and geometric properties than the algorithmic pi currently used. So, let me present one of these particularities that I find interesting, and that would also represent a proof of its validity. It refers to what I call the cycle of pi squared, and which relates the square circumscribed to the circumference, 8, with the number pi of its inner circumference, and in which the operating decimal number, 10, is used to maintain the level of operations, of powers and roots, close to unity, that is, at the level of the dimensions we are using. This cycle function is simple, and as the name implies, it is cyclic since the input result of the mathematical function is the same as the output result, if the correct number pi is applied. It is represented geometrically by a cycle or roulette on which we can rotate or maintain the circumference of the square of pi without its value changing with the cyclic function applied to it. However, if we add a non-exact value of pi to this loop, then the circumference of squared p is quickly distorted and destroyed. Simplifying, the cycle would be like a tour in continuous rotation through a circle of value pi squared, in which tour this value of pi squared is analyzed and tuned in each turn by the cyclical function exposed, in such a way that if we have applied the correct value of pi, the cycle and value of the circumference remain unchanged indefinitely. But if the applied pi is not correct, the circumference wobbles and destroys quickly, the faster the greater the error in the applied pi. In the same sense, with a variable of this cycle, and with a correct number pi, we must measure, through powers and roots, all the squares and circumscribed circles on a first given circumference.